So this is the third lesson in Chapter 2. We're going to talk about graphing linear functions. A lot of this will be review from Algebra 1, but it's worthwhile because we use linear functions so much in modeling different scenarios in life. So okay, what is it we want to accomplish? Number one, we want to determine whether a function is linear. Number two, we want to know how to graph a linear function given 2 points, or perhaps a table, or perhaps we're given an equation, or we're given a point and a slope. So in each circumstance, we want to know how to graph the linear equation. Our vocabulary is linear function, slope, x-intercept, y-intercept, and slope-intercept form. Who uses this? Meteorologists can use linear functions to predict when a hurricane will reach land. They begin tracking hurricanes' distance from land when it is 350 miles off the coast of Florida and moving steadily inland. The meteorologists are interested in the rate at which the hurricane is approaching. So for example, here's a table of data. The time value is in hours and the distance from the land is in miles. And so by inspecting the data, we know that each time value in hours is separated by 1. 1 minus 0 is 1. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. And the neat thing here is that the values of the distance in land are also equally spaced. 325 minus 350 is negative 25. 300 minus 325 is negative 25. 275 minus 300 is negative 25. And 250 minus 275 is negative 25. And so because everything is equally spaced, we can say with confidence that this data can be represented with a linear model, a linear equation. Now the rate is expressed as change in distance over change in time. The change in distance for each case is negative 25, and the change in time for each time is 1 hour. So the hurricane is moving 25 miles per hour closer each time. Functions with a constant rate of change are called linear functions. A linear function can be written in this form. You're used to seeing y equals mx plus b. Well, in intermediate algebra, we're going to consider y as a function. So we're going to write it as f of x equals mx plus b, where x is the independent variable, m and b are constants. The graph of a linear function is a straight line made up of all of the set of points that satisfy the equation. So, first thing we're going to have to know how to do is how to recognize a linear function. Now the way that you do that is you take what's called a first level difference. You take the differences of all the x values, 2 minus 0, 4 minus 2, 6 minus 2, and you take the differences of all the y values. 2 minus negative 1, 5 minus 2, 8 minus 5. And if you get the same difference every time for the x and the y, you can say that the data set is linear. So the rate of change here, the change in f, is 3. The change in x is 2, so the slope of the line is 3/2. Now for part B, we can see that there's a problem here. While it's true that the x values are all separated by the same constant, the y values are not separated by the same constant. And so the data set in part B is not linear. Now I want you to pause this video and I want you to try example 1A and 1B, the check it out problems. And then I'll give you the solutions afterwards. Can they represent linear functions? 11 minus 4 is equal to 7. 18 minus 11 is 7. 25 minus 18 is 7. Negative 15 minus negative 6 is negative 9. Negative 24 minus negative 15 is negative 9. Negative 33 minus negative 24 is negative 9. All the differences are constant, and so yes, this is a linear function. 8 minus 10 is negative 2. 6 minus 8 is negative 2. 4 minus 6 is negative 2. Okay, that's fine. 5 minus 7 is negative 2. 1 minus 5 is negative 4. We have a different number. So that means that this is not a linear data. This is not a linear function. Excuse me. The constant rate of change for a linear function is called the slope. The slope of a linear function is a ratio. It's the change in f over the change in x. From Algebra 1, we know that to be the rise over the run. Now, the slope of a line is the same between any 2 points on the line, and you can graph lines by using the slope and a point. The next thing you're going to have to know how to do on your homework is how to graph lines using slope and a point. So can we graph the line with a slope of 2/3 that passes through 1, 1? Step 1, what we do is we graph the ordered pair 1, 1. Write 1, up 1, put a point. Now we use the slope. The rise is 2, the run is 3, and we put a new point. The rise is 2, the run is 3, we put a new point. And that's how you graph the line using a point and a slope. Example B, the slope is negative 1/3, and the ordered pair is negative 2, 3. Left 2, up 3. There's the point. Now we can use the slope in 2 different ways. We can go down 1, there's my negative 1, and to the right 3, so there's my new point. Or we can go up 1 and then left 3. Either way is a valid way of using negative 1/3 as a slope. And so that's how we graph the line. I do want you to try example 2. So pause the video and try example 2. Plot the ordered pair 3, 1 first, then use the rise over the run to get another point. Now recall from geometry that 2 points determine a line. Often the easiest points to find are the points where a line crosses the axis. The y-intercept is the y-coordinate of a point where the line crosses the y-axis. The x-intercept is the coordinate of a point where the line crosses the x-axis. So here's the next thing you have to know how to do. You have to know how to graph lines using intercepts. Find the x-intercepts of 2x minus 3y equals 12 and then graph the line. Now, if you're going to find the x-intercept, what you have to do is you have to set y equal to 0. So you substitute the y value with the number 0. And so this becomes 2x minus 3 times 0 equals 12. 2x equals 12, and that means the x-intercept is 6. Now to find the y-intercept, you set x equal to 0. So you substitute x for 0. 2 times 0 minus 3 times y equals 12. So negative 3y is 12. So y equals negative 4. We now have the 2 intercepts. The x-intercept is 6, 0. The y-intercept is 0, negative 4. And we graph the 2 intercepts and plot a line. Quick word of caution. The intercept is a single value, not an ordered pair or a point. I'd like you to pause the video, and then I'll tell you the intercepts in just a moment. Okay? See if you can find them. The x-intercept is negative 4. The y-intercept is 12. Linear functions can also be expressed as linear equations of the form y equals mx plus b. When a linear function is written in the form y equals mx plus b, the function is said to be in slope-intercept form, because m is the slope of the graph and b is the y-intercept. Notice that the slope-intercept form is the equation that's solved for y. Next thing you have to know how to do in this homework. You have to know how to graph functions in slope-intercept form. So first, I'm going to give you the equation 3x plus y equals 5. This is not yet solved for y. So to solve for y, we subtract 3x to the other side, and we get y equals negative 3x plus 5. Now, negative 3 is the slope, and 5 is the y-intercept. So what we do is we rise up to 0, 5 and put a point. Then we use the slope of negative 3. We rewrite negative 3 as negative 3 over 1. So the rise is down 3, right 1. Down 3, right 1. And that's how we graph the line. It is also possible to use a graphing calculator to graph. So choose the standard square window. That means negative 10 to 10 for the x min and x max, negative 10 to 10 for the y min and the y max. And since I have a nice little TI program right here, I might as well just show you how to do it. So let me go ahead and do that. Let's turn this on, clear the window. I'm going to hit the y equals button. Let's type in negative 3x plus 5. Let's make sure the window is standard, which it is, and then I hit graph. And there it is. There's negative 3x plus 5. Now, how about the equation 3 halves y equals x minus 3? Well, this is not yet solved for y. So to solve for y, we multiply both sides by the reciprocal of 3 halves, which is 2/3. So I multiply 3 halves y by 2/3, and I multiply the grouping of x minus 3 by 2/3. This gives me y equals 2/3 x minus 2/3 times 3. 2/3 times 3 is 6/3, and so that's 2. So the slope is 2/3, and the y-intercept is negative 2. Graph the ordered pairs 0, negative 2. Now we use the slope. Rise 2, run 3. Put a new point. Rise 2, run 3. Put a new point. Write each equation in slope-intercept form, then graph the function. Go ahead and pause the video, and then I'll tell you what the slope-intercept form is. For 4a, the slope-intercept form is y equals 2x minus 9. For 4b, the y-intercept is 1/3 x minus 2. An equation with only one variable can be represented by either a vertical or a horizontal line. So let's look at the following table. On the left, this is what a vertical line looks like. A vertical line always has the equation x equals a constant. So this is the line x equals a. A horizontal line always looks something like the graph on the right. A horizontal line always has the equation y equals b. So the first thing you need to study and you need to remember is what a vertical line looks like versus a horizontal line. The slope of a vertical line is undefined. The slope of a horizontal line is 0. Next thing you have to know how to do on your homework. You have to know how to graph vertical and horizontal lines. Determine if each line is vertical or horizontal, then graph. X equals negative 3. Because the only variable is x, that means it must be vertical. It goes through x equals negative 3, and it's a vertical line going like so. Y equals 1. Y is the only variable, and so this must be horizontal, going through the y value of 1. Really quickly, determine if each line is vertical or horizontal. Ready? 5A is horizontal. 5B is vertical. And the next thing you need to know in your homework is how to apply these different kinds of linear functions. Suppose a road rises from 2,500 feet above sea level to 7,000 feet in 10 miles. Find the average slope of the road. Graph the elevation against the distance. All right, we compute the rise. The rise is the calculation 7,000 minus 2,500. And so that's 4,500 feet. The distance to get this rise is 10 miles. So we have to do a conversion. We've got to convert miles to feet. 5,280 feet in 1 mile, so there's 52,800 feet. That means the slope is the ratio of 4,500 to 52,800, which is approximately 0.085. And so what that means is the slope rises 0.085 feet per foot. So you go up 0.085, you run over 1 foot. You go up 0.085, you run over 1 foot. The y-intercept is the original altitude, that's the 2,500 feet. So that's 0, 2,500. And the ordered pair 52,800, 7, that's the altitude after 10 miles. And so these 2 points fit the data. Because the graph has different scales for the x and y axis, the slope of the graph appears steeper than the slope of the actual road. Think about this one. A truck driver is at mile marker 624 on Interstate 10. After 3 hours, the driver reaches mile marker 432. Find his average speed. Graph his location on I-10 in terms of mile markers. And that is the lesson. So that was lesson 2.3, graphing linear functions. God bless you, wherever you are today.